Hello, lighttracerrender has got an update to version 2.40. This release brings real-life physical simulations, convenient selection mechanisms, a faster interactive mode, and many other improvements. Let's take a look at one of the coolest features, the physical engine. Let's say you want to place one ring on top of the other. Typically, you will need to make a lot of small movements and tilts while checking from different views that there is no intersection or gap between rings. It's a laborious and boring process. The new update brings a convenient mechanism for that. In the Transform widget, a new group of settings has been added, which is responsible for physics. By default, all objects in the scene are static. It has to act as static obstacles. Any selected object can be turned into a dynamic one. Such objects can be moved and rotated in a physically plausible way, and they will not penetrate static objects. For our case, let's keep the first ring static, and make the second one dynamic. Now we can start the physical simulation by clicking this button. Let's pull the ring down, and it will fit into a physically plausible position automatically. It is so easy. If you need to place a lot of dynamic objects in the scene, you can use the gravity factor setting. If gravity is enabled, after releasing the object it will fall straight down. Objects will take a physically plausible position, meeting certain obstacles. Note that multiple dynamic objects can be manipulated at the same time. Just select them together and pull them with the 3D manipulator. Because dynamic objects use their own movement mechanism, you cannot select static and dynamic objects at the same time. This limitation only applies when the physics simulation is running. If it is disabled, the selection works without restrictions. Physical modeling entails some limitations. First, the engine does not support non-convex dynamic objects. For this reason, if the dynamic 3D object is non-convex, lighttracer builds its approximation with a set of convex hulls. This operation is slow, so by default, the shape accuracy is set to a minimum value of 1. You can improve the accuracy of the geometry representation by setting more convex hulls per object. For example, for our ring we use the accuracy set to 32. The physical simulation puts additional CPU overhead, so it can slow rendering down a bit. For this reason, once you have finished positioning scene objects, it is recommended to turn it off. Write in the comments what you think about the cool new feature. Thanks for watching, see you in the next video.